Hello, it's dumplet here. Here's an item on geometry. So take a look at the figure. We have two rectangles inscribed in the same circle. The orange one is a 3 by 11 rectangle, and the blue one is a 7 by 9 rectangle. The overlapping region, highlighted in green, has an area of m over n in lowest terms, so m and n are relatively prime positive integers. We're asked to get the value of m plus n. Credits to the American Invitational Math Examination for this item. As usual, pause this video if you'd like to give this item a try, but if you're done, let us dive into the solution. Now, since we do have rectangles here, there's a lot of right angles, and well, a very classic approach to solving an item like this one, or any geometry item, is to take a look at probably angles, size that are probably the same, or they have like similar ratios. So, well, a little bit of a spoiler here. We are going to use similar triangles here. But then again, it's not really a very difficult concept. It is a concept that I'm gonna say it's obvious sometimes, but you know, it's very hard to see them or to spot them. But in this case, it would be very simple because we do have take a look the two highlighted red angles over there because we do have rectangles. Now we can do some angle chasing and kind of say that, okay, we have vertical angles here highlighted in black. Let's just say both of them are, let's just say x for now. Let me just make this alpha, right? Just to, right, there we go. So we have two alpha here to indicate the two vertical angles. And we're going to have 90 minus alpha here and then 90 minus alpha here, all right? So we can obviously see that we do have a pair of similar triangles. I'm going to highlight them. So this small red triangle is similar to this. I'm going to use green to highlight it. So this green triangle. So those two triangles would be similar. And now that they are similar, we could try to form like a ratio. Now, before we do anything else, though, we don't know what the other sides here are. So let me just randomly set some variables. Let's just say this portion is x and then this portion is y. So since we do have a 3 by 11 orange rectangle, so this entire thing must be 11. So if this thing is x, then this part would be 11 minus x. And then we do have the other rectangle to be a 7 by 9. So if this part is y, this part would be a 9 minus y. And we should be able to form a similarity. Now, to form the ratio, to form the equation from the ratios, we just simply take a look at the proportional parts. The corresponding parts. So take a look, how did I form this ratio? I did 3 divided by x is equal to 7 divided by 9 minus y. Now this came from the smaller triangle. The 3 minus x came from the smaller triangle. This 7 divided by 9 minus y came from the bigger right triangle. And that's the ratio of the blue angle, the side opposite to the blue angle, divided by the side opposite the green angle. All right. So just make sure that we have these. Make sure you get the corresponding sides correct to get the correct ratio. Now this is an equation in terms of x and y, so I could easily relate x and y. Let me just clear the denominators. I'll have 27 minus 3y is equal to 7x. Just put all the variables to one side. So 7x plus 3y is 27. So we have one equation in terms of x and y. So it would be nice if I have another equation in terms of x and y. So I could solve for x and y in two equations. Now, luckily for us, there is another easy equation we could form. We do have a lot of right triangles. Specifically, I'm going to focus on that one. That motivates us to use the Pythagorean theorem. All right? In the Pythagorean theorem, in this triangle, we're simply going to get 3 squared plus x squared is equal to y squared, or just simply 9 plus x squared. That's going to be equal to y squared. So I have one equation here, another equation here, and we can easily solve for x and y here. Now there is a bit of a problem though, because x and y are actually pretty big. X and y, if I try to solve for one in terms of the other, now let me bring the other equation here. The 7x plus 3y is equal to 27. Now if I solve for, actually we have to kind of make sure what we need in the given, because we want to get the area of the green region. We can easily see that it's a parallelogram. because of how the symmetry, because of how we have symmetry in the figure. So I mean, it is a parallelogram. You can easily verify from the figure, and you can easily angle chase to verify that this is indeed a parallelogram. So, well, we technically have the height of the parallelogram already. This part is technically 3, so essentially it would be nice if we can get this 11 minus x. We want to find x. So let me just solve for y in terms of x in this equation. So y would be equal to, well, 27 minus 7x divided by 3. And I have to put it into this formula. I would have to square this, and yes, it is doable. I just don't want to do it because it's pretty long. So I'll show you guys, I'm going to say a little bit of a shortcut here to help us get x in. Not really probably it's going to take a bit, it's going to take the same time, but you know, we get to discover more about the question because we could do an additional thing. We're going to consider, well, we do have a circle. So essentially I'm going to label points A, B, C, D. All right, they are cyclic, sure. But what's more important is that, well, AC and BD, they are chords. So this portion, AP times PC, I let P to be the intersection of the two chords, the AC and the BD. So as the name suggests, we have the intersecting chords theorem. All right. And okay, I'm just going to write down AP is Y, PC is 9 minus Y. So Y times 9 minus Y. That's going to be equal to BP is X, PD is 11 minus X. So I'll have 9y minus y squared is equal to 11x minus x squared. A bit of manipulation, 9y minus 11x is equal to y squared minus x squared. Now, y squared minus x squared, coming from this equation, we should be able to get that y squared minus x squared. Coming from the Pythagorean theorem, it's going to give us 9. So we're going to have, I'm going to write this as negative 11x plus 9y equals 9. And this is another equation in terms of x and y, different to this one. So we now have a system of equations for x and y, and I believe this is a shorter way for us to get x. But then again, you guys could try to substitute the y in, solve for x. You're going to get the same thing. But I'm just saying that this is a little bit long because I'm going to square big numbers, and it might be more difficult to get the solutions for x. But anyways, in this new method, or I'm going to say the shortcut, or the shorter method, I guess, to get x, essentially it's just a system of linear equations. Equation 1, equation 2. Let's do it in the next slide over here. We just have to get x, because as mentioned a while ago, the 11 minus x is going to be the base. The height is going to be the 3 for the shaded region, which is essentially a parallelogram. Now, I'm going to multiply 3 to the first equation. So I'll get 21x plus 9y is equal to 81. So, and then the second one is still like this. I'm going to subtract the second equation from the first. So I'll get 32x is equal to 72. So I'll get x is equal to 72 divided by 32. Both are divisible by 9. Sorry, by 8. So it's going to be 9/4. So x will be 9/4. Let's put the x in here. So we know that the base of the parallelogram, or the green area, it's going to be 11 minus 9/4. That's going to give us 44 minus 9 over 4. So that's going to be 35 over 4. So that's going to be our base, 35 over 4 times our height. Our height is 3. So it's going to be 105 over 4. And that's going to be the in lowest term. So m plus n is going to be, m is 105, n is 4. So we're going to get the final answer of 109. Okay? And that is indeed the final answer. And the reason why I didn't want you to show you the quadratic equation is that, well, take a look at the value for x that we got. We got x to be 9/4. It is going to be relatively difficult for us to factor this thing. It's going to be, I'm going to say, tedious to factor that one. But then again, both methods work. I just wanted to show you this additional way to kind of make our lives easier in the calculations. All right. Anyways, hopefully you guys learned something new from this video, and I'll see you in the next one. Bye-bye.